is CORDIScovery. Hello and welcome to this episode of the CORDIScovery podcast with me, Abigail Acton. Today we'll be exploring how EU researchers are tackling pollution for a cleaner, greener Europe. In many areas, the pandemic has reduced our impact on the natural environment. But what will happen when we emerge from the restrictions and fire up our economies once again? What impact will that have on pollution levels? From oil spills that threaten our seas to the stinks that ruin our day, pollution touches us at every level. Can we as individuals really collect the data needed to get policymakers to tackle odour pollution? And if it takes time for industry to improve the quality of air in our urban environments, what can we do to make the air at home and in workspaces safer? We can take steps to clean up the air around us in the environments we control, but how can we deal with larger scale pollution like oil spills and wastewater discharge? Today's three guests have all been supported by the EU's Horizon 2020 programme in a bid to provide some solutions to these issues. I'm happy to welcome Rosa Arias, who is the coordinator of the DNOSES project. A chemical engineer with a background in odour pollution, her particular focus is on citizen science and science communication and how that supports responsible research and innovation. Rosa is involved in the Spanish initiative Science in the Parliament. Hello, Rosa.
Hello.
Senior Technology Advisor at ISCLEANAIR and Senior Tech Lead at the Connected Places Catapult, Dr. Fabio Galatioto is interested in transport and the environment, air quality, and the innovative transition to sustainable cities. He was involved in the APA project.
Hello, everyone.
Dr. Ioannis Dontas coordinated the Impressive project. He is the Senior Consultant at Aratos Limited and Director of Research and Development at the Aratos Group. His focus is on the use of Earth observation data in various industries, but mainly on its application to environmental protection. Ioannis is also interested in innovative ICT. Welcome, Ioannis.
Hello.
Rosa, you are the coordinator of the DNOSES project, which gives people the tools they need to track and register the nuisance smells that trouble them. Of the various types of pollution that people could be identifying, why did your team select odour?
I've been involved in odour pollution since 2004. It's a type of odour pollution that constitutes the second cause of environmental complaints after noise, accounting for around 30% of the complaints. But measuring odours is not easy, so regulating odours is not easy either. That's why odour pollution is under-regulated, usually at the global level and in many European countries. And we have an advantage here, which is that our nose is the best sensor that we can have to measure odours. That's why we come up with a new methodology based on citizen science to monitor odour pollution. That's why the project DNOSES was born.
Okay, yeah, you're right. I mean, we walk around with a perfect sensor to judge this. And in fact, most of the time we're smelling things that, occasionally maybe we don't like, but we can't really register that data. So it's great that you gave people the tools that they could. What tools did DNOSES give people to record hard facts and bring those to the attention of the authorities?
We have two main tools. The first one is the International Odour Observatory. In there, we provide information in odour pollution to any type of person that is interested. And we also have maps there where you can find affected communities by odour pollution all around the world. You can add your own and also regulations in odours. But we have a second tool, which is an app, which is called Odour Collect, where any people can map odour observations wherever you are, in any place, at any time. It is real-time data that helps us understand in which areas this pollution happens, monitor and understand the problem with the intention of finding situations of improvement to increase the quality of life of the citizens affected by the pollution.
And can you give us some idea of how many users are using the tool and also the website? And maybe you could give the website address.
Yes, the website is odourobservatory.org, O-R-G, and also the app is odourcollect.eu. So you can also find it in the web. And we have now more than 9,000 odour observations all around the world and more than 1,000 users, active users, mapping observations in our case studies and beyond.
Oh, that's pretty impressive. Do you have any examples of how users and authorities are responding to the tools that you give them? Are they finding that it gives them the power to try and change the context that's bothering them?
Yes, for example, in Barcelona, I want to explain you something funny because we like to co-create everything in our project. So we involve all types of stakeholders, the environmental authorities, the citizens, of course, the scientists, and the other emitting industries. And since the project was focused on odor pollution, we didn't add in the app the option to map good smells. And the citizens in Barcelona asked us to include this option because they mentioned that in this area, yes, they have some other issues related to waste and wastewater treatment plants, but sometimes it smells nice, so they also wanted to map. And now the AMB, which is the metropolitan area of Barcelona, which is the environmental authority in charge of the emitting activities, they are using our data to compare it with the industrial processes to find matches of the other episodes to see what was going on there, to try to find and reduce and establish other management plans and increase the quality of life of the population.
Oh, that's fascinating. So you actually have direct, concrete examples of how this can actually be harnessed to change things. Because I think people feel very frustrated sometimes when they look at problems like pollution around them and feel that they can't do anything about it. That's really interesting, Rosa. Thank you. Does anyone have any questions to Rosa? This notion of citizen science, I think, is very interesting.
Yes, I have a question.
Yes, Fabio.
Okay, thanks, Rosa. My question is about actually the potential combination of your platform with tools like air purifier, like APA, that can actually intervene when and where is needed from communities or local authorities.
Yes, thank you for your question. The connection is very clear because, of course, we need systems such as air purifiers or others, biofilters, etc., to reduce the odor pollution on the population. So we can first map, for example, before you install an air purifier with the citizens involved, and then after the installation, we can demonstrate the efficiency in the reduction with the observations of the citizens. So it's totally connected.
That's great. Thank you.
That's a good synergy there. Very good. Super. Well, Fabio, thank you for asking that question. And of course, this now brings you into the conversation. People can use tools such as those offered by DNOs when they're out and about. But how can we at individual levels change our own environments? Now, I know that the APA project developed some really interesting next generation air purifiers. The project was run by ISCLEANAIR. The air purifiers that you've developed strip out a wide range of pollutants, both at domestic and industrial levels. I've always wondered just how effective air filters are, Fabio.
Thanks, Abigail. From my position as an advisory role in the project, ISCLEANAIR, I've seen they developed a new concept of air purifier, and this is based on water, and their tools are actually being applied not just at the industrial level where the project was focusing, but through the time they have been able to also have consistently impressive results on and certified also by third party, both on particles matter, airborne pollution, and nitrogen dioxide, which is something that in urban area is very important. And they have been able to reduce up to 50% on outdoor spaces the particles and 35-40% the nitrogen dioxide, and in particular in tourism application like Milan and Tel Aviv. I think also this concept in terms of particulate matters is very important at city level, which is going to be very important, especially once you implement electric vehicle, that component won't go away straight away. And this is important because APA is not only focusing on particle matter PM1, PM10, so larger size, but also very nanoparticles as low as 10 nanometers.
10 nanometers, that's tiny. That's smaller than viruses. So can your panels also filter out viruses? A question, obviously, that's on most people's lips at the moment.
Yes, and that's exactly my point in that sense. Very small particles, 10 nanometer is 10-15 times smaller than viruses like coronaviruses, we are all know now. And this has been certified will be before actually the pandemic has started off. And for this reason, the ISCLEANAIR has received with their APA panel the certification as Class 1 medical device from the Italian Ministry of Health. And very recently also, because they are the only one using water, you can think about the possibility to sample their water and check if there is a presence of viruses within the water, even killed already, because the system can kill the virus. But actually, you can detect if in an indoor environment there is a presence of threats from virus.
Oh, that's fascinating. So, in fact, it could also be a way for health authorities to track the spread, if they could find a way of doing this effectively or efficiently, at least. A little bit like tracking the spread of the virus in the sewage systems as well. So
Correct.
In the air and it's an interesting way of gathering data.
But in a local actually application, because you can do indoor and not in a quarter or a large city scale.
Yeah, no, fascinating. That's very interesting. So you mentioned water being a major part of the technology and how these panels function. Could you explain to us a little bit about the dimension of the panels and how much air they can purify, and also how it works?
Yes, exactly. Basically, they are based on water, and their size is of the APA system panel is about 2 meters by 1 and 40 centimeter depth, like the one used in cities. And they require only less than a kilowatt per hour to clean up to 4,000 cubic meter per hour, which is quite a lot in a urban area. And also they, because they don't use filters, but just water, they basically reproduce the cleaning power of the rainfall, the natural rainfall. And this is also important because without the filters, they are actually reducing quite a lot the burden in terms of changing the filter, also consuming more energy over time. And they literally continue to clean at the same rate every day for months. And the water use has been certified to be clean as a rainfall, so they can be discharged on normal sewage. And that is sort of the most sustainable way, and that has been recognized by the Solar Impulse Foundation a few days ago, has been launched. And in terms of the opportunity, I think, is not just about the air pollution abatement, but we see filters, not actually the competitors, but potential opportunity in there, because in a recent project we have been funded from the Italian government, we are introducing a near zero air pollution building concept, where the ISCLEANAIR has proposed to attach their system into an air treatment unit. And they usually get very obstructed by the filters by particles, increasing exponentially the energy consumption. And by integration of APA system with their units, you can reduce up to 25% the total energy consumption.
Oh, that's excellent. So it's sort of a combination of the two systems can actually be greater than the sum of each individual part. That's fascinating, very interesting. And are you locating these on streets or, everywhere, people's houses, streets, hospitals, or at the moment, where in particular?
I mean, so far, more than 130 installations have been done by ISCLEANAIR, both in indoor, outdoor, industrial, urban area. We have recently won an innovation grant for testing the virus as well in an indoor environment related to medical, and also in as small as an office space.
Excellent, absolutely excellent. So I look forward to being able to buy one.
Yeah, we are in discussion actually with large groups to scale up.
Fantastic. I look forward to that. Does anyone have any questions for Fabio? It's a very fascinating technology, I think.
I have a question.
Thank you, Rosa.
Fabio, I really like your idea. It's wonderful. And I wonder if we can have a connection also with others, because with Odour Collect, you can map smell of traffic in busy streets, for example, which, as you know, they have a lot of particles in the air. And there is a lot of another citizen science project, which is measuring particles with low-cost sensors. And I wonder that maybe we can combine in these busy streets your technology. My question for you is if you think that this could be useful for the citizens.
Yes, definitely. And that's why I'm asked the question before, because I think your system can actually detect where the problem is not just known, but perceived. And that's very important in terms of message for awareness, but also for health benefits. And just recently we heard about the Kurt Law case from the little child that has been recognizing air quality and PM in particular as a key element within, or factor within.
Yes, this is referring to a case that occurred a while ago, but finally has been the death of a child has finally been attributed officially to air pollution and a consequent asthma attack caused by severe levels of air pollution.
Yeah, as a contributing factor. Yeah, not the only factor, of course, but as a contributing factor, and it is very important.
Right, absolutely. Thank you very much, both of you. Well, that sounds like there's some interesting synergies and potentials there. Good. Ioannis has been working on a project called the Impressive Project, and the Impressive Project has been looking at how to tackle pollution on a perhaps not on a different scale, but in a very different environment. The Impressive Project is concerned with maritime pollution, oil spills, and also wastewater discharges. So, Ioannis, if I could turn to you. Sometimes it takes a machine to get a job done. Can you tell me a little bit more how the Impressive Project is using drones and unmanned vehicles to track pollution?
Yes, thank you, Abigail. Actually, we wanted to go further beyond the traditional methods of oil spill inspection and monitoring. This is the basic scope of this kind of work. Oil spill inspection and quick inspection and monitoring of the behavior of the oil spill or the wastewaters in the maritime area, in the outside of the harbors and in their vicinity. So we just use an octocopter drone and a small catamaran, a small ASV, a vehicle sailing over the sea, in order to go over the area of the oil spill and take a small sample of it and check it later on and inspect the oil spill and its behavior. That was the initial idea of it.
And how did your idea develop? What sort of data are you able to collect?
First of all, we need to have something as an initial triggering effect. This initial triggering effect for the existence of a potential oil spill somewhere can be delivered from the Earth observation data from the satellites who monitor all over the Earth all the time.
Okay, so if I may interrupt you, just to be clear, so you get some data from Earth observation satellites, and that might indicate that there is a spill or a discharge event happening. And at that point, what do you do?
Exactly. And then we have this indication of the oil spill, and automatically an octocopter is getting off and goes over the area, the suspicious area for an oil spill, and takes some high resolution pictures in order to give more evidence to the initial triggering information from the satellites. Then, if the authorities have the proof that this is indeed an oil spill, a small catamaran can go automatically at this specific area and get with a robotic arm a small sample of the polluted water and take it back to the laboratory for testing. This is the way the port authorities can have in their hands strong evidences for oil spills or wastewaters from ships in order to pursue the ship owners for this kind of pollution.
That's fascinating. So basically, these are tools to bring polluters to justice in a way, to ensure that the polluter really does pay. Can the data that's picked up by these autonomous vehicles give you the information to actually identify who potentially the polluter was? Do you get enough granular data to be able to pinpoint who has actually made the discharge or where the spill has come from?
The answer is yes and no. It depends on the timing. Everything is depending on the correct timing, because when a ship is passing by outside the harbor, the satellite may have a picture of it from the previous hours. And of course, everybody knows the specific position of the ship and specifically the port authorities. The drone can have a picture of the ship also if the ship is in the same position at the time it discharges the wastewaters, for example. We can catch the thief at the very moment, and this is the whole idea. And of course, the catamaran, the catamaran cannot have does not have a camera on it in order to inspect, but until we send automatically the catamaran to take the oil spill sample, we already know who is and what he has done.
So, people have been extracting samples of spills and trying to identify the perpetrators of pollution events for a while. Your system is autonomous. Can you let us know specifically what the main differences are and why your approach is so useful?
Yes. First, I can tell you that it's a question of precision, it's a question of cost, and it's a question of safety. We need precision in order to know exactly who has done what and at what exact time. Of course, we need to cut the costs of, we do not want to send people over there to do this job anymore. People did this work a lot of times in the past, sometimes successfully, sometimes not successfully, and we want to cut the costs down of it. And of course, it's a question of safety for the workers of the port authorities who could go there and take the sample if the weather is bad, severe or whatever. It's better the machines do this kind of job more accurately sometimes and more safely for us.
I think also you mentioned, of course, the need for real-time information and speed and rapidity, so that perhaps the person, the perpetrator of the pollution event, has not gone too far or can still be identified. I guess also deploying these systems that are automated is also more rapid than trying to get a response, a human response, a group of people together.
Yes, exactly. Such a system can be used by the port authorities for constant monitoring of the maritime area around the harbor and all the vicinity of the several other areas, the coastlines, etc. And such a system can be used constantly, 24 hours per day, 7 days a week, in order to provide constant information about the status of the sea surroundings. And of course, this is the basic use, of course, of such a system. It can be used further. It's a system that can be used for other types of monitoring, pure environmental monitoring, I could say. The height of the waves, we can have such measurements from the satellites. We can induce these measurements into the system of ours and have the drones make some more accurate measurements in order to justify the satellite measurements, etc. Scientists love those things.
Yes, and maybe algal blooms. Yeah, algal blooms as well, perhaps, eutrophication, where there's a sudden rush of algal blooms that show up on satellites. I can see that perhaps sampling those could be really useful for data as well. No, that's absolutely fascinating, Ioannis. Thank you very much. So Fabio, Rosa, do you have any questions to put to Ioannis?
Yes, I have one question.
Yes, Rosa.
I wonder that what triggers your methodology is the Earth observations, right? So I'm wondering how quick you can act after this, and if you think that maybe citizens can help you monitoring also the spills or other phenomena that you want to report. Because just as an example, the European Environmental Agency has an app which is called Marine Litter Watch, which is informing directly the European directive on pollution, marine pollution. And it's not focused on spills, it's more on marine litter in the beaches, etc. But perhaps a combination of both could help identifying quicker these spills so that you can act quicker if Earth observations are not quick enough, which is my question.
Thank you, Rosa, for the question. My answer is that the Earth observation data sets for this kind of job can be frequent enough for this for the use in our work. We can have several measurements from satellites per 24 hours. And apart from that, in order to cover the remaining time slots of the day, we can use the drone in order to inspect the overall area outside of the harbor. On the other hand, I could say that citizen science is indeed used for litter or garbages in the sea, and it is a successful movement. But regarding oil spills, I think that it's not easy to involve the passengers of another ship to take photos and give such kind of information easily, because they are almost very near to the level of the oil spill and they cannot see it very easily when they are passing by from another ship, for example. The oil spills or wastewaters are more easily seen from above, either from satellites or from drones. And this is why we use this methodology. Of course, it is a very nice idea. Perhaps in the future, citizens flying over the areas with helicopters or small airplanes, we could use this capability.
But it's the bird's eye view. You really need to get the idea of the expanse. I hadn't thought of that because I was also interested very much in Rosa's question. It seemed like a logical point. But as soon as, of course, you mentioned the notion of the fact that if you're actually down on the water level, you can't really get a clear idea of what's actually happening in terms of the extent of the spill and so on. Yes, absolutely. Johannes, I have an extra question for you. I'm wondering whether the data that your systems have collected have actually ever been used to bring perpetrators to book. In other words, have you ever had your data used in criminal cases, or have they been used to assert liability?
The only thing I can tell you is that regarding some recent incidents of oil spills in Greece and Spain in the last 5-6 years, if there was this solution on air, we could have avoided this very big, the destroyed environment of these activities. Actually, our solution has not been used in some court or anything similar because we are ending the project at this time. We are still in the demonstration stage.
Absolutely.
At this time. But we hope in the future, yes.
Sure.
We have already some positive reactions from port authorities.
Yes. So perpetrators, watch out. A drone is coming to you. Yes. Excellent. Yes, Fabio.
My question was about actually applying not just on sea, but also on rivers. Because actually rivers, there are also industrial emissions. And that could be, actually, I heard in UK, there were quite a lot of spills from industry that are not detected.
Exactly. It can be used, of course.
I was wondering how big has to be the surface water to detect any spill.
No. We are currently monitoring rivers and lakes from satellites, and we get a lot of valuable data. Imagine that we can detect from satellites the concentration of nitrogen or oxygen or other substances diluted in the water of lakes and rivers. So we have the required resolution to do this, of course.
That's wonderful.
Okay.
And by the way, I have a case study in DNOSIS where we are investigating industrial spills in rivers, in one river in Portugal, which is called Rio Tinto. So yes, we can have a connection, but we are investigating them by the smell, like citizens walking by. If they smell chemical products or something in the water of the river, then they map. And we are understanding if they come from industries or not.
Yeah, if the smell is translated actually in reality to a small fog or a cloud or something, it can be seen from the satellite. Imagine that a satellite can detect the hydrocarbons getting out from a broken pipeline. Gas pipeline, for example, and it can see the concentration of the hydrocarbons nearby the pipeline crack. So yes, you can have a satellite information just for comparing your own methodology.
Yes. No, that is a new field that is opening, like the connection of citizen-generating data and satellite data. So for me, it's super interesting.
Very interesting for all of us.
So I really love both of your projects. Yes.
Abigail, I think we could have a very nice discussion.
Yeah, you see, I brought together 3 very interesting people, huh? Okay. Well, I really want to thank you all very much for sharing your time with us this morning and for talking through your really fascinating projects. I like the way that you're all tackling one common problem, but from rather different angles. And Fabio and Rosa, who knows whether there might be some synergies that could develop between your 2 technologies and your approaches. Johannes, we all really wish you a huge amount of luck in the future with regards to being able to bring people to book. I really hope that the information you manage to get from the data can actually be used to pin people down for liability and responsibility. Thank you so much for joining us this morning.
Thank you.
Thank you, everyone.
Thank you.
Interested in what other EU-funded projects are doing to tackle pollution? Take a look at issue 102 of the Research EU magazine, available on the CORDIS website, cordis.europa.eu. From blue sky speculative research that opens the doors for tomorrow's technologies, to research tightly focused on finding solutions to the challenges we're facing right now, CORDIS highlights work being done in a wide range of fields. Daily news articles, interviews, a magazine, and research packs exploring projects from specific domains. The CORDIS website has your next long read or coffee break skim through. Interested in applying for EU research grants? Visit the website to see how your work relates to that currently being done in your field. So come and check out the research that's revealing what makes our world tick. Our next episode pokes its head into the virtual reality revolution. What novel devices are coming our way? Will they transport us to new worlds, change the way we learn, bring people together? Join me to find out. We're always happy to hear from you, so drop us a line, editorial@cordis.europa.eu. Until next time.